Hey folks, welcome back. In this video, we're going to go over a couple of the things that we had issues with in the first show with this truck, starting with the rear steer. So in our first couple of shows, we ended up breaking a couple of cylinders, had to make a repair, and ended up breaking those cylinders again. I put my spare cylinder on here and broke it immediately, and I believe that the root of the problem is the fact that the hydraulics are just uncontrolled. I could steer left and right, no problem, but when you would turn one direction, it would just not stop for the most part. It would just continue to turn until it hit the end of the stops being the hydraulic cylinders. So as the steering would go uncontrolled clear to the full end of the stroke of the cylinder, it would hit the end of that cylinder and then end up breaking the swivel eye mount on either the rod end or the barrel end of the cylinder. Now, beefing up the cylinders and making those attachment points stronger is definitely on the list to do, and that is one of my goals. I already have that pretty well sorted out. But really, the root of the problem is lack of control in the hydraulics. So I think that what is going on is the fluid is being forced out of the cylinder by mechanical leverage on the knuckle, back through the hydraulic system and through the solenoid valve. I believe the spool in the solenoid valve is just not designed to handle that kind of pressure. Since then, I've reached out to a couple of people and talked to them. One of them is Jeff Bainter. If you're familiar with that name, then you know that he's been involved in the monster truck industry for many, many years. When I was talking to him, he had asked if I was running a lock valve on my rear steer system. I had to ask him what a lock valve is because in the rock crawling world, we don't need anything like that. You know, we can rely on that spool in the solenoid valve to actually block the ports and keep the tires from turning. So he just told me, you know, it's a lock valve is just something that they run in line in the hydraulic system as close to the cylinders as possible, and it keeps hydraulic fluid from backfeeding through the system when you get that mechanical leverage on the tires. So I researched that a bit and found out that a lock valve is actually a dual port pilot operated check valve. And the way that works is just another block, kind of like the bypass relief, the dual bypass relief on the front. Only instead of having relief valves in there, it has check valves. So it stops the fluid from returning from the cylinders back into the system. You have a check valve that is stopping that and holding that hydraulic fluid in place. Now, when you apply pressure to turn one direction, that pressure is also applied to that check, which releases that fluid and allows the fluid to return back to tank in the opposite line as the line that you're applying pressure to turn. So that makes complete sense that I would need that in this system. And I, jumped online, found one for about $100, and I've got that one sitting on the shelf here. So we're going to get that plumbed in. But first, I need to repair all of my broken cylinders. My first step in making this repair was to order a pair of new cylinders. I'm going to start with two brand new cylinders, just like what we're on here. And what I'm going to do is take those cylinders, completely disassemble them, and remove the rod from the cylinder, then remove the piston and the gland, the seal head, so I don't have to worry about damaging any seals or anything like that. Once I get it fully disassembled, I will take the rod end of the cylinder and cut the swivel eye off of the end. In the last video, you can see where I had posted a picture of where that part had snapped off of the rod itself. So what I'm going to do is cut that part off, set it to the side, and then I'm going to drill and tap the end of the actual chrome rod and fit it for a regular thread-in heim joint. I've got 1-inch 14 taps, so I can drill and tap that rod and install a set of brand new 1-inch heim joints with 1-inch through holes. Then what I will do with that swivel eye that I have taken off of the rod end of the cylinder that I cut off, I'll clean that up and I will use it to repair the two that I actually broke that swivel eye out of the barrel end of the cylinder. So I'll end up cutting the broken parts off of the two used cylinders that I just took off of this truck and replace it with those new swivel eyes that I cut off the rod ends. To reinforce that, on top of welding those parts on, I'm going to cut out basically some reinforcement rings that will weld to the barrel and completely weld around the circumference of that swivel eye. Just kind of reinforce and try and beef all of that area up. Just give it more weld to hold it to the barrel. So I think that combination of reinforcing that swivel eye, installing a real thread in heim joint in the rod end, I think that will end up being a pretty stout combination. Once that is all done, then I'm going to get those remounted, replumb the rear steer, and plumb in that dual port check valve. Now, by doing what I've got going on now, I'm going to end up with 4 cylinders that are beefed up with thread in rod ends and then the reinforced swivel eye on the barrel end. What I'll do is put 1 pair on the rear and 1 pair on the front. Then I'll take the front cylinders that have not been damaged and I will have those to set aside. They will be easy to swap on for spare cylinders if I need to. I also have this one that's been on here for a total of about 3 minutes of operating time, that all I need to do is repair this swivel end here, and it could also be a good spare. This one, since I have to weld on it anyway and disassemble it, I may go ahead and replace this swivel eye with the one that is welded on the rod end and do the same procedure to it. Cut it off, drill and tap the rod, fit a threaded heim joint in place of that, use this rod on the barrel, and beef it up. Then I'll have a complete spare, beefed up cylinder. So before I get to disassembling these things, I have to build a little bit of tooling. I have to build a spanner wrench that actually fits onto the threaded gland in the end of the cylinder. And then I'll probably end up building a couple of blocks so I can actually clamp that cylinder to the table, hold it firmly in place while I break that gland loose or the seal head loose and get them all disassembled. So let's start with building a couple of tools and go from there. Here I've got these blocks that I just finished machining on the Bridgeport. I just used a hole saw to match this contour of the this profile of the cylinder, so I can get as much surface area gripping as I can. And then I've got it turned down so that this particular boss or this fitting is actually touching the table. And then I built this spanner wrench out of a piece of 3/8 plate. It fits these notches in the seal head or the gland. What I'm going to do is try and break the threads loose on that fitting so I can pull this cylinder apart and work on it in pieces and not have to worry about burning up seals or anything like that while I weld on it. Well, that went pretty easy. Easier than I was expecting. Quality. Right from China. Well, that's what we got, so we got to try and make it work. Okay, I've got this shaft, the rod, out of that cylinder. You can see I've pulled the piston off of it, and I've got that tractor eye cut off of this end. So now what I want to do is chuck this up in the lathe, machine this back closer to this paint line to gain me a little bit more room, and then drill and tap the end of this rod right here and fit it so I can use a regular rod eye like this right here. Now this shaft has to stay, you know, in good shape. This chrome, you can't damage the chrome finish, otherwise it'll leak all over, damage the seals. So what I did was I took a piece of this quarter wall aluminum and slotted it, kind of like a collet. So my thought is I can put this in the lathe, and then when I grab onto it with the jaws of the lathe, it'll crimp down and grab onto that shaft, and hopefully it doesn't damage the chrome. Even if it spins in the lathe, the aluminum shouldn't damage the chrome. I should be able to clean that up. But if I were to grab this shaft with the jaws on the chuck of the lathe, and it were to spin in there, say when I'm trying to tap this hole down here, it would certainly damage this finish, and that thing right there would basically be garbage. Just throw it in the pile for something to build later. Hopefully this will work. We're gonna go give it a shot. I've got all four of these rods drilled and tapped, so they're ready to go. These here are the swivel eyes that came off of the two brand new cylinders. I've got those cut off, obviously. They're all cleaned up. And these are the reinforcement rings that I got cut out. I cut those out on the plasma table while I was doing this wrench. These are actually a 5/8 material. I'm not 100% sure what material it is. It's pretty stout. It's a little tougher than A36, I'm pretty sure of that. Needless to say, I'll be doing a little preheat before I weld that just because of the unknown material. But here you can see how the swivel eye fits in that part. It's pretty snug fit, and that should reinforce that and keep it from breaking the side out like the other ones did. Here are the brand new cylinders that I've disassembled, and you can see how that reinforcement ring fits on there. I think I'm going to go ahead and probably clean this weld out a little bit so I'm not relying on whatever porosity filled China weld we've got going on there, and just TIG weld this whole assembly to the drum. So I've got two of those ready. And here's one of the original cylinders that I had actually broken the rod, the side out of that swivel eye. Went ahead and cut all that material off of there and then chucked them up in the lathe, turned it off nice and flat. You can see that heat affected zone, or the martensite zone, where I had added a bunch more weld to the end of this cylinder, trying to reinforce that just in this weld area. It worked. I mean, it didn't come off of there, but it ended up breaking this piece out the side here. So I've got both of these are ready to go. What I got to do now is clean up my welding table, which is a filthy mess, get set up and start doing some welding.
A few moments later.
As indicated in the time lapse, I got all 4 of these cylinders welded up, so I don't think I have to worry about these swivel eyes popping off the cylinders anymore. While I was at it, I set each one of these up in the Bridgeport and machined this fitting down. So these things are pretty tall when you get them from the factory. And by taking about 300 thousandths off the top of this, I can still fit a Boss O-ring fitting in here just fine. I've put a chamfer in there for the O-ring. And this just gives me more room between this cylinder and the housing when it's bolted in place. It's not so much a problem on the rear steer because I'm running number 6 AN fittings or JIC fittings. On the front, I'm running number 8, and that size, the fittings for the hose and everything just requires a bit more room. So I went ahead and did that on the 2 new cylinders. The other 2 were already done. Then I come out and clean these up. So these things had a little bit of surface rust in them. I'm sure it's probably from a long boat ride over here. It wasn't really too bad, but there's no point in running these seals through it. So I borrowed a little ball hone and just cleaned them up, put a little pattern in it. They should be good. Got them all 4 of them honed, and then took them to the solvent tank, cleaned them out really good, and then I assembled the rods with the gland and the pistons. I used that collet again in the lathe to hold this rod while I assembled this and torqued these nuts. Used a liberal amount of red Loctite on those as well. So I think right now all I've got left to do is sit down and get these final assembled. Go ahead and put these pistons and rods and glands back into each one of the barrels on here. And the cylinders will pretty much be ready to install at that point. All right, I got a couple of these cylinders all assembled and ready for installation. I thought I would just take a minute and show you a little comparison of what we've built versus what they started out as. So as you can see, these threaded rod eyes, even though these are just cheap, probably China-made rod ends, still quite a bit beefier than this junky tractor swivel that we've got going on there. And then on this end, you can see this one's been busted out. This one was the one that happened at the Washington show. Same swivel, it's just beefed up with that 5/8 reinforcement plate. So now two of these cylinders, these two here are gonna go on the rear axle of the truck. The front cylinders are all assembled and ready to go with the exception of these rod ends. The pine cone that packed these up and shipped them to me sent me two left-hand thread ones. Now I actually went back and checked my order and make sure I didn't order some kind of kit with a right and a left-hand thread. But no, I actually ordered 5 right-hand thread rod ends and they sent me 2 left-hand threads. So got an email sent to them, see if I can get the right parts here. Needless to say, I can get the rear assembled, but the front will probably have to wait until next week. So I'll get these, get this rear end tore apart and get to cleaning up the hydraulic mess, the hydraulic oil mess, and try and get these cylinders put on. Next step will be the dual port check valve and some new hoses for the plumbing. Now I've got the rear axle pretty well disassembled, at least to the point that I need it to get these cylinders reinstalled. Thought I would show another change that I have to make. So these are the spacers that keep that cylinder centered in the knuckle here. And this here is the ball that came out of that broken swivel ball that I just showed you on the table there. And as you can see, it fits in here pretty snug. It goes in there, take my word for it. This ball is 1 inch wide. So we're gonna have to shorten these spacers, each one about 3/16 of an inch, because this ball is 1 inch wide and this one is 1 3/8 inches. So I've got to take a 3/8 of an inch total, make this gap here wider by 3/8 of an inch. So to keep it centered, we'll take 3/16 off of each one. Then I should be able to slide this rod end in here. That's pretty short work on the lathe. And now I've got a nice fit on this rod end here in the knuckle. So now I can continue on with reassembly, I think. Maybe a little more cleanup, and then we'll get these cylinders bolted in here. Well, I've got everything reinstalled. All of the plumbing is done. Not nearly as clean as it was when there was just a simple 2 hoses coming down here, 1 to each cylinder. But we'll kind of go over this and kind of explain why this is necessary. So this is that dual port check that I was talking about. As you can see, each port coming out of the bottom has a T-fitting. So now I am running both ends of the cylinders plumbed. So this fitting here is teed with this line going to the rod end of the cylinder, while this fitting is going to the barrel end of this cylinder. So as fluid is applied to those sides of the pistons, that cylinder will extend, this one will retract, making the tires turn the front towards the passenger side. So obviously it's the same left and right. And then this dual port check, what it's doing is locking this fluid in these lines here and in the cylinders. So as you turn one direction, this fluid would be returning back and going back to the pump. Now, the way the dual port, the pilot operated dual check works is as the pressure is applied in one line, it is opening that check so that the fluid can return back up the other line. So if there is no fluid applied, then both of these ports are checked and fluid cannot go back up to the pump. I'm hoping that that control in the hydraulics fixes my whole rear steer problem. I have one more thing to do before I can bleed the system, and that is change or repair my solenoid valve. I'm not 100% certain that there's anything even wrong with the solenoid valve, but it's had that backflow through there. I'm going to at least pull the spool out, inspect it, and maybe at the minimum put a new spool in the block that's in the truck. So I'm going to take a look at that now and make an effort to try and get this thing topped off with oil and get this system bled before I have to go back to work tomorrow. Well, I went ahead and pulled that cartridge out of the solenoid valve and looked it over pretty good. The spool in the cartridge moved really smooth, really freely. There was nothing damaged. No O-rings were damaged. Like I said, the spool moved freely. As far as the aluminum block of the valve itself, I think it would be really hard to damage that part. So I went ahead and put it back in. I did compare it to the new spool that I have, and you know, the functions and movements, everything feels the same. So I didn't really feel like it was gaining anything to steal that new cartridge out of a new valve. I just put this one back together. I think it's going to be fine. I went ahead and topped off the oil, and I've cycled the steering back and forth a couple of times. Everything is pretty good. It's a little bit slow, so I'll show you here real quick. So the slower speed was kind of to be expected by plumbing in both ends of the cylinders. So I'm not surprised, you know, that it ended up slower. I'm gonna go ahead and try it. I'm not sure if I'm gonna wait until I run it the next show and see how it works, or maybe next day's off, I get a couple other things done. I will tire it up, run it around the block, and see how I like it. In past experience, I have found that really fast rear steer can be, you know, as much of a hindrance as slow rear steer. So it's kind of sixes either way. I know everybody likes fast rear steer, but slower, very controlled rear steer, I think that might be fine, especially as good as this truck turns on the front steering. Either way, if I decide that I do need faster steering, I always have the option to wire this pump up at 24 volts, and that would really increase the speed a lot. So I may look into that, just to you know, keep that option in mind. We still have a few more things to do before the truck's ready to go to another show. We'd like to move the seats, and then we've got a couple other safety things with our Hans units that we're looking into. I'm going to save that for another video. I think that would be good content on a video all its own. As far as this video, I'm going to go ahead and call the rear steer done. The only thing really left to do or upgrade on the steering is to replace the front cylinders once I get those rod eyes, you know, those heim joints to show up. As for this video, I'm going to go ahead and wrap it up. As always, thanks for watching. Have a good one.